Hello, my name is Harry Schultz with Waypoint Technology Group, and in today's video tutorial, we'll be using the Trimble Access Field software to configure, perform, and download a static survey. So let's get started by going into the software here. And we need to first start by creating a survey style or editing your existing survey style. So I'm going to come to Settings and Survey Styles, and I don't have a static survey style on the list, so I'm just going to create one. Some people will call it static, some people will call it fast static. It's really just a measure of how long you plan on occupying these points at what epic interval. We're just going to call it static for now. And the style type is either GNSS, conventional or integrated. For this, we're using GNSS. And we'll start in the Rover options. So the survey type will be fast static. Pick the appropriate receiver you're using. In my case, I'm using R12i. I'm measuring 2 meters to the bottom of the quick release. So this all looks good. Now you have two options here. You can log your raw files to the controller or the receiver. Typically, in a Rover type of survey, out in the field, we're using the measure points. That's what these settings pertain to. You're going to have the controller with you while you're measuring these points, so it just makes the most sense to log the files to the controller, and you can download them from the controller at the end of the day. However, there is one advantage to logging to the receiver, and that is you can log more satellite constellations. So if I'm logging to the controller, I come down here and I can just pick GPS, L2C, and GLONASS. But you notice if I change my logging device to receiver, now I have additional satellite constellations that I can also log data from. So just wanted to point that out. It can be important in certain situations. For this example, we're going to log to the controller. Most of the course sites that I'll be post-processing against log at 5 seconds, so I'm going to drop this down to 5 seconds. And if you want to give each of your raw data files a unique name using some predefined naming convention, you can do that here. I'm going to elect to auto file name. So that's what we're doing here. And I'm just going to turn the tilt functions off for this particular example and hit accept. So that was the Rover options, and anytime you go in the field and select measure points during a static survey, these are the options that sort of workflow is drawing off of. If you go into the field and you select start base receiver, these are the options that the survey style will be drawing off of. So again, I'm going to switch this to fast static. We'll use the same type of receiver for this particular example. Maybe we're measuring to the R10 extension lever, and I'll keep the antenna height a question mark, so I'm always prompted out in the field to enter that height, and there's no default value. Down here, we will log to the receiver this time, because typically when you go out and start the base receiver, your intention is to take the data collector with you for some other task. So we wouldn't want to log to the controller here, because that would mean we have to leave it at the base station. So let's just keep that as receiver. Again, I'm going to set my logging interval to 5 seconds. There's a lot that depends on what your logging interval is at, depending on what type of survey you're doing and how long the occupation times will be. So I'm going to go ahead and log all the data that I can from these other satellite constellations and hit accept. So in the fast static point, there's predefined times for a point measured with a different number of satellites. You can use this. Typically, people are doing different things with these raw files. If you're going to Opus, you're going to have to measure the points for at least 20 minutes to begin with, regardless of how many satellites you have. But again, this is all really going to depend on the satellite visibility, the accuracy that you're looking for, the baseline length, in other words, the length between your rover and base receiver. So things like that will kind of determine how long you need to stay on these points for. All right, so that's it for configuring the static survey style. I'm going to hit store, and we're ready to start surveying. So to tell the software which receiver I'm going to start with, I'm going to go to Settings, Connections, and Bluetooth, and we'll start in Rover mode with my R12i. So now that I have the software looking for the right receiver and the right mode, I can go to Measure, pick our new fast static or static survey style, select Measure Points, and because I have the R12 toggled in as the Rover, it initiates that connection. So we'll just wait a second for that to connect. And now it's connected. It started the survey. I see I have 12 satellites, and we're ready to give the software a point name. So call this Rover 3. The method is a fast static point. It took our antenna height from the survey style. It has the right measurement point. And here we have some different amounts of time that we could log for the different satellites. I'm going to start my measurement here. And you can see that the survey has started logging. So again, the time that you spend on each point is going to be project specific. I'm going to pretend that we've logged for at least 20 or so minutes here, and I'm going to go ahead and store that point. And after you've stored the point, you can go to the point manager and see job file. I'm in a named projection, a state plane coordinate system, so I have coordinates. But because all these points are going to be post-processed, you really don't need to be in a named projection. You could have gone over to your job, and when you set the properties up, you could have just selected no projection, no datum, which would have just allowed you to work in latitude, longitude, and ellipsoidal height. So just whatever your preference is there, we have different options. Okay, so that's measure points using the Rover, and let's start a base survey now. So I'm going to come back to measure. I'm going to end the current survey. No need to power down the receiver just yet, but I do want to go ahead and tell the software that I'm going to use this same receiver as a base station now. So I need to come into my Bluetooth connections and toggle the Rover to none, and then just set this same receiver as my base. If you had a different Rover receiver than you did a base receiver, obviously you could put each of them in here separately. Okay, so now we've toggled that on, and now if I want to initiate a connection to the base, it automatically does that by going to Measure, Static, and Start Base Receiver. So now it's initiating that Bluetooth connection to the receiver, starting the survey. A little different interface here because we elected to start base receiver. So I'm just going to call this base 3. Point name, and here, okay, it's just telling us that we don't have any coordinates in our job file for a point named base 3, which is fine because the intention of the survey is to gather raw data and compute a position for base 3. Okay with that warning. Let's say we're on a tripod here and we're measuring 5.4 feet. And that's to the lever of R10 extension. And then I hit start base receiver. And now the base is started. If you were to look on the receiver itself, the power light should have a slow blink, which means that it's logging raw data to the receiver. Okay, so now that the base is started, I can take my data collector and hook up to the rover or the robot or whatever I might be doing while this base station is off on itself collecting data. All right. So now let's pretend that we're at the end of the day and we want to extract these files. So those files that were logged to the rover were, logged using the rover were logged to the controller. So they're already in the data collector. But this base survey that we did logged to the receiver. So there's two ways to get those files off of the receiver. One is using a flash drive and a short cable that came with your R10 or R12. And another way is to connect from Trimble Access to the receiver and pull those files out of the receiver into the controller through Bluetooth. So to do that, we're going to hit the burger button here. We're going to go to Instrument. We're going to go to, let's see, Receiver Files and Import from Receiver. So here I elected to have the software auto name the files. So what's happening is you're seeing the last 4 digits of the logging device. In this case, it's the Trimble R12 that I'm using. So 0205 is the last 4 of the serial number on that unit. 318 is the Julian day of the year, and then 0 is the session number. So this was the first survey that I started, and here's another survey that's going. It's got a lock because that's still running right now. So I wouldn't be able to download that one, but here is a file that I can import from the receiver into my data collector for download. So I just select import and start, and it will copy that file out of the R12 in this case and into my TSC7 or whatever controller you may be using to run Trimble Access. Okay, so we're going to keep in mind what the name of this file is, so we look for it later. We know that that is the correct file. All right. Okay, now it's time to download our data. So what I'm going to do is create a folder for my data. And I'm going to come over to the burger button and the jobs menu here. I did all of my logging within the static 2. So I'm going to have that job file selected and come to the copy button. We have different tabs here. For this type of workflow, we're going to be copying job files to. Here is the job that we're copying from called static 2, and then I'll pick that destination folder on my desktop. Okay, and down here we want to make sure that you have copy linked files enabled, and that's going to grab the raw files that we collected as a Rover in addition to the base file that we imported using Bluetooth from the receiver into the controller. So it's important that you accomplish that before you go through this copy routine so that it does in fact have that base file that it can also grab and export or copy in this scenario. So with that, you can also create a job XML, which is alternative to the .job and gives you a little more versatility than the .job. Not so versioning specific. All right, so I'm going to hit copy. And now if I visit my data folder, you can see that we just created a Trimble data folder. And inside the project subfolder, we have Waypoint Technology Group, which we're logged in as. We had the JXL that we told the software to create, the original job file, and then we have a related files folder. Inside this related files folder, we have the .to2s from the actual Rover file. So this is one of the Rover points that I measured. And then we have that base file that we imported from the R12 base receiver as well. And there's the naming conventions here is a little different because these were collected in the controller. So they have this different designation here. It happens to be the identification for my laptop here that I'm using. But here we log to the R12 receiver. So we have that 02053. And basically that's the serial number of the receiver there. But you have your raw files right here that can be brought into Trimble Business Center and post-processed, or they can be converted to Rhinex and sent to Opus. All right, that's all I wanted to show everyone today. I thank you for joining me, and I hope you have a great rest of your day.